Hello, this is Jeremy. So this episode is going to be a little different, like yesterday, where I drew out the computer diagram. However, I have found my tablet, which is great. I got it working. So the topic for today is going to be binary. Actually, go to binary and teach what binary is. So what binary is a two-state number, or two-state numbering system. Typically, it's 0 and a 1. And these are the two states. You also will see false and true. But you could use any state you want. You could have red and green. You could have black and white. You can have brown and yellow. You can have whatever. So that is the basis of binary, is two separate states. Why do we use only two different states when we do binary on a computer? Because that's actually the easiest to handle, and computers operate off of electricity. So the presence or non-presence of electrons, or electron flow, can determine 1 or 0. So if you have electrons going this way on a circuit, this could be a 1. They go this way, this could be a 0. The cool thing about a binary system is anything that you can represent a one state or another can be done in binary. This can be the presence of something, like electrons, or a direction of flow, or anything. Typically, computers have binary based off of voltage. But I'm not going to get into that. It's not really that important for this. What I want to do is go over binary as it relates to numbering systems. So that's in the context of going to cover binary. All right. So with a binary, there's a binary digit, and it's called a bit. And it's written like this. It's just short for binary digit. Binary digit. And you can think of this, sorry, this is not quite right. Swap this out. And then digit. No, wrong. That's how I see it. Binary digit bit. There's lots of things in computers that use this whole naming convention where they put together words to make new words. Pixel's another one, which is picture element. Anyways, what I want to do is I want to go, alright, so when we have one bit, that's one digit, and the one digit can hold two states. It can either be a 0 or a 1. That's two states. When we add in another digit, we get more states. So to have an example, we have 0, 0 for two digits, 0, 1, 1, 0, and 1, 1. These are all the different combinations of 1s and 0s you can have. I'll do 3 digits as an example, but I will run out of space if I do much more. So let's just do 3 digits as an example. So we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. If you count these, there should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's going to show you the combinations. And to be able to do things fast, like that, it's fairly simple. So the first digit is the ones place, like normal. Then instead of the tens place is the next digit is actually the twos place. And then we have the fours place and the eights place. And we can put it probably slower. So we have the ones place, the twos place, fours place, eights place. So you should notice that when you go between these, this is 2 times. So 2 times, 2 times, 2 times. When you do with decimal, like normal, it's 1, 10s, 100s, and 1000s. And this is a 10x. Between each jump. This is 100, 10, 100, 1000. 1, 10, 100, 1000. So, knowing this, we can use this to figure out how this number relates to these. And we can say, so 1, 0, 1, 1. Okay, so we have a ones place, that's a 1. We have no twos place, so that's a 0. We have a fours place, so that's a 4. We have an eights place, so that's an 8. We add these all together. We get 12 plus 1, 13. This is how we represent, this is how the computer represents numbers in binary. And it can add together numbers, it can do multiplication, it can do division, and we can also do logical operations. So what I'm going to cover is logical operations with this, and that should be it for the video. Okay, now we're going to do logical operations. The first logical operation is the easiest one, it's the not. Wow, that line is not straight. That's better. Not much better, but better. Okay, so what I'm going to show you is a truth table. And what these do is they show you that if you are given an input called A, and the output is usually denoted Q, I believe. If I remember correctly. But it could be anything. So the 2 inputs a not can operate on are 0 and 1. And what the not does is it inverts it. So a 0 becomes 1, and a 1 becomes 0. So they become the opposite. That's what a logical not operation does. And computers, when they usually handle binary data, they usually do it on a whole set of numbers, or a whole bunch of binary digits. So you'll usually have a number like 0, 1, 0, 1. And when you do not on this, you will get 1, 0, 1, 0. It does all of these bit operations all at once. All right, so that is a logical not. The next operation that I will cover is OR. So we have logical OR. This takes 2 inputs. It takes an A input and a B input, and outputs Q. So for this, we have 4 possible inputs because we have 2 bits of input. So there's 0, 0, 0, 1, 1, 0, 1, 1. Okay, so for the rule for OR is if anything is a 1, the output is a 1. If nothing is a 1, the output is 0. So the way you can think about this is it's one, that doesn't work well, one or the other. That's not really a good way to think about it. So we'll just go with what I said first. If there's a 1 in any of the inputs, there we go. If there's a 1 in any of the inputs, if anything is 1, it's a 1. So this is kind of any. So that's how you can read it out. If there's a 1 in any of the inputs, it's a 1. If there's a 0, obviously there's not 1, so it's a 0. Okay, that's the OR. The next one is AND. This accepts 2 inputs as well. Most operations use 2 inputs, and they output usually one bit. We have 0, 0, 0, 1, 1, 0, 1, 1. Okay, the way AND works is all of the bits need to be 1 for it to be 1. So 0, 0, 0, 1. Only 1 is that, so that's not all of them. That's 0. That's not all of them. That's 0. That's all of them. So we got a 1. And of course, we have AND being done. This will be 1, 0, 0, 1. And just for an extra practice, we'll convert this into decimal. So this is going to be the 8th place plus the 1st place. So there's zeros in the 4th and the 2nd, so we're going in the 1st, so that's 9. Okay. These are the most basic ones. The next one I'm going to cover is XOR, which you could make with ANDs and NOTs and ORs. And to be honest, you can do everything with 2 operations. You can use a NOT and an AND to make all operations. For example, you can do, we have to do 2 inputs. So if you do NOT and NOT A, and then NOT B. I believe that works, but it doesn't fit. NOT B. I'm pretty sure this works. To make an OR. Or we might have to make this. But I think this is what's necessary. Okay, I'm not going to mess around with this. But just know that you can do it. I have to think about it. and work it out, and it's not really appropriate for this demonstration. So let's go into XOR. So XOR has two inputs, A, B, and output is Q. So you have 0, 0, 0, 1, 1, 0, and 1, 1. XOR is short for exclusive OR. This one is if one or the other is true, but you can't have both true. So in the case of here, 1 and 0, and 0 and 1, you have a 1. In the case of 1 and 0 here, you have a 1. Or they're the same, you have a 0. And that is XOR. This covers basically all the logic operations that you'll need to know. And let's see, there's anything else that I need to address. Let me look at my notes. Okay, that looks like everything. Have a great day.